Everybody's happy. Okay. I forgot to just think back down. Trouble. How many people are having trouble with Blackboard?
Oh, there you
There
go.
it comes. It's just slow.
Oh.
It's getting old and slow. Okay. By the way, if you're not doing it already, you really ought to check in and at least alert from time to time on the discussions on Blackboard. We've had some really interesting discussions about cohort versus age and since last week about memory. So a really interesting group of people. So, I get a kick out of this article, and I'm holding on to it for a while for a couple of reasons. One is it's probably the only article I've ever seen on sensation and aging that cuts across a lot of different kinds of sensory modalities. And it also makes a point of some of the high and low frequency differences. So you've got taste, smell, was it cooling, low frequency vibration, high frequency vibration, low frequency hearing and high frequency hearing, all in the same study. And they also do some interesting things. They're a little more sophisticated about the whole threshold idea than a lot of researchers in this area tend to be. And it, basically, the way you do sensory threshold research is you have people like sitting in a lab, and you're exposing them to different, whatever the range of physical stimuli are that you think are somewhere around threshold, which is the level at which people can start to reliably detect that the stimulus is there. And as a participant, you're sitting there saying, yes, I feel, hear, taste, whatever the stimulus, or no, it's not there. And so the threshold is where your yes and no starts to go reliably in the direction, not perfectly, but just reliably different from 50-50 in the direction of being able to detect the stimulus. One of the things that they talk about that actually not a lot of people in this literature talk about is that people, if you do this with people multiple times, you get different estimates of the threshold. Now, here's another thing about the ways of thinking about statistics. I'm going to take up on a little historical digression for a minute. Statistics, some of the first people working on developing statistics were involved in two different fields that had, because of the nature of the fields, they had different approaches to thinking about variability. One field was astronomy. And so what astronomers noticed that you try to estimate the position of stars or distance or whatever based on your observations of stars through telescopes. And different people using the same equipment in the same place come up with slightly different answers. Or the same person making multiple observations of the star come up with slightly different answers at different times. So, since you don't think that the star is actually moving around, we think that it's error. That you get individual differences that are creating noise in your data and creating confusion about where the star actually is. Or there are weather conditions and other things that have nothing to do with where the star actually is that are affecting your measurements. So if that's the way you're thinking about that variation, you average your observations together in order to get the real answer of where the star is. This is what Stevens et al. In this article are doing when they decide to take 4 different threshold measures on each of these 7 sensory thresholds and take the average of them. Is that they feel that everybody actually has a threshold for each of these things that ought to be constant. Each of you in this room would have a different threshold for low frequency vibration, but your threshold, in their view, ought to stay the same. So that's their tradition of statistics they're picking up on. Another history stream for statistics is people looking at agriculture. And the question is, you're planting different kinds of corn in a field that's supposed to be the same otherwise, and you're doing all the same agricultural techniques differently, and you want to know which of these types of corn is going to produce the most corn or the tallest corn or whatever it is that you're particularly interested in doing. And you know going in that, like almost all biological entities, stalks of corn vary. You don't think it's error. I mean, you look on the cornfield and they're different heights. So there really is variation. And you're still interested in the question of, on average, does this type of corn grow taller than this type of corn? But you don't expect that all the corn is going to be the same height in this group and all the corn in this group is going to be the same height. Coming back to Stevens et al., personally, and I see this more and more as I get older, it makes a lot of sense to me that, in fact, people may have different sensory thresholds at different points in time. I mean, I know, like looking at the dashboard in my car, that some of the smaller readouts are easier to see some days than others. And so I think that my sensory threshold for static visual acuity does vary at different points in time. I suspect, although I don't have any real clear-cut data on this point, that my hearing varies across days and so forth. So, yeah.
What about if you have, like, your vision, because I've noticed this at night, your vision reading is different from your vision during the day, but it's consistently different, then that wouldn't be a threshold because you're measuring it at 2 different times of the day?
You'd at least have to look into the question of whether it's the background light or how fatigued you are.
I think it's fatigue.
There's lots of different reasons for that could be true.
I wear different glasses when I read it. For reading, whereas during the day I can wear my regular glasses.
Yeah. But yeah, you'd want to be controlling other variables and influences that all the ones you'd be aware of. The other thing that I like about this paper in 2 different ways is that they, unlike a lot of people doing sensation or cognitive research, they get concerned about the question of whether the people in the study might be demented or not. This is starting to change. Actually, 5 years ago, I thought it was starting to change. Now I'm thinking that it may be changing back again. But for at least for a while, cognitive experimental aging researchers were starting to show some signs of actually trying to do some kind of screening for the possibility of dementia in people that were in the studies. I think some of the stuff I've seen published in the last few years, it seems like many of them are kind of going back to the assumption that if the person can make it into the lab and complete the task, they must not be demented. But since we're like really, really bad at recognizing, even clinical people with expertise in dementia are fairly bad at recognizing early stages of dementia, it seems like a risky bet to me. So it's actually pretty cool that they decided to do the Boston picture naming and the lexicological